The purpose of this video is to look at the solution of elementary simultaneous equations. Before we do that, let's just have a look at a relatively straightforward single equation. The equation we're going to look at is 2x minus y equals 3. This is a linear equation. It's a linear equation because there are no terms in it that are x squared, y squared, or x times by y, or indeed x cubes. The only terms we've got are terms in x, terms in y, and some numbers. So this represents a linear equation. We can rearrange it so that it says y equals something. So let's just do that. We can add y to each side so that we get 2x equals 3 plus y. I did say add y to each side. You might have wondered what happened here. Well, if I've got minus y and I add y to it, I end up with no y's at all. Here we've got 2x equals 3 plus y. So let's take the 3 away from each side. 2x minus 3 equals y. So there I've got a nice expression for y. If I take any value of x, let's say I take x equals 1, then y will be equal to 2 times by 1 minus 3, which gives us minus 1. So for this value of x, I get that value of y. I can take another value of x. X equals 2. Y will equal 2 times 2 minus 3, which is plus 1. Another value of x. X equals 0. Y equals 2 times by 0 minus 3. Well, 2 times 0 is 0, and that gives me minus 3. So for every value of x, I can generate a value of y. I can plot these as points. So I can plot this as the point 1, minus 1. And I can plot this one on a graph as the point 2, 1. And this one on a graph as the point 0, minus 3. So let's just set that up. Pair of axes. Let's mark the values of x that we've been having a look at. So that was x on there and y there. And let's put on the values of y that we got. When x was 0, our value of y was minus 3. So that's there. When x was 1, our value was minus 1. And when x was 2, our value was 1. Now, those 3 points lie on a straight line. Y equals 2x minus 3. And that's another reason for calling this a linear equation. It gives us a straight line. Okay. You've got that one, y equals 2x minus 3. Supposing we take a second one, 3x plus 2y equals 8, a second linear equation. And supposing we say these two are true at the same time. What does that mean? Well, we can plot this as a straight line. Again, it's a linear equation, so it's going to give us a straight line. Now, I don't want to have to work out lots of points for this, so what I'm going to do is just sketch it in quickly on the graph. I'm going to say when x is 0, and cover up the x term, 2y is equal to 8. So y must be equal to 4, which is going to be up there somewhere. And when y is 0, 3x is equal to 8. And so x is 8 divided by 3, which gives us 2 2/3. So somewhere about there, 2 2/3. And we know it's a straight line, so we can get that by joining up through there. And this is the equation 3x plus 2y equals 8. So what does it mean for these two to be true at the same time? Well, it must mean it's this point here, where the two lines cross. So when we solve a pair of simultaneous equations, what we're actually looking for is the intersection of two straight lines. Of course, it could happen that we have one line like that and a parallel line. They would never meet. And one of the examples that we're going to be looking at later will show what happens in terms of the arithmetic when we have this particular case. But for now, let's go back and think about these two. How can we handle these two algebraically so that we don't have to draw graphs? We don't have to rely on sketching. We can calculate, which is so much easier in most cases than actually drawing a graph. So let's take these two equations. And we're going to look at two methods of solution. So we're going to look at method 1. Now let's begin with the original equation that we had. 2x minus y is equal to 3. And then the one that we put with it, 3x plus 2y equals 8. Our first method of solution. Well, one of the things to do is to do what we did in the very first case with this and rearrange one of these equations. It doesn't matter which one, but we'll take this one so that we get y equals. And we know what the result for that one is. It's y equals 2x minus 3. So that's equation 1. That's equation 2. So this is now, let's call it equation 3, and we got it by rearranging 1. What we're going to do with this is, if these two have to be true at the same time, then this relationship must be true in this equation. So we can substitute it in. So let's substitute 3 into 2. And so we have 3x plus 2 times y. But y is 2x minus 3, and that's equal to 8. And you can see that what we've done is we've reduced this to this equation, giving us a single equation in one unknown, which is a simple linear equation, and we can solve it. Multiply out the brackets. 3x plus 4x minus 6 equals 8. Gather the x's together. 7x minus 6 equals 8. Add the 6 to each side. 7x equals 14, and so x must be 2. That's only given us one value. We need a value of y. But up here, we've got an expression which says y equals. And if we take the value of x that we've got and substitute it in, therefore y will be equal to 2 times 2 minus 3 gives us 1. And so we've got a solution, x equals 2, y equals 1. Are we sure it's right? Well, we used this equation, which came from equation 1, to generate the value of y. So if we take the values of x and y and put them back into here, they should work. Should give us the right answer. So let's try that. X is 2. 3 times by 2 is 6. Plus y is 1. 2 times by 1 is 2. 6 and 2 gives us 8. Yes, this works. This is a solution of that equation and of that one. So this is our answer to the pair of simultaneous equations. Let's have a look at another one using this particular method. And the example we're going to use is going to be 7x plus 2y equals 47, and 5x minus 4y equals 1. Now, we need to make a choice. We need to choose one of these two equations and rearrange it so that it says y equals, or if we want, x equals. The choice is entirely ours, and we have to make the choice based upon what we feel will be the simplest. And looking at a pair of equations like this, it's often difficult to know which is the simplest. Well, let's pick at random. Let's choose this one, and let's rearrange equation 2. So we'll start by getting x equals this time. So we say 5x is equal to 1, and I'm going to add 4y to each side, plus 4y. Now I'm going to divide throughout by the 5 so that I have x on its own. Now I've got to divide everything by 5. Everything. So I have to put that line there to show that I'm dividing the 1 and the 4y. So this is a fraction. Now I'm sure you can tell this is not going to be as easy as the previous question was. In fact, it's going to be quite difficult because I have to take this now, and because it came from equation 2, I'm going to have to take it and substitute it back into equation 1. And this isn't looking very pretty. So let's give it a try. Sub 3 into 1. So I have 7x, but x is this lump of algebra here. 1 plus 4y all over 5 plus 2y equals 47. Now you can see this is becoming quite horrific. Multiply throughout by 5. Why? Because we're dividing by 5, we want to get rid of the fraction. The way to do that is to multiply everything by 5, and it has to be everything. So if we multiply that by 5, because we're dividing by 5, it's as though we actually do nothing to the 1 plus 4y. So that leaves us 7 times 1 plus 4y. We need 5 times that. That's 10y. And we have to have 5 times that. Remember, an equation is a balance. What you do to one side of the balance, you have to do to the other. If you don't, it's unbalanced. So we're multiplying everything by 5. So 5 times 47, 5 7s are 35, 5 4s are 20, 235 altogether. Now we need to multiply out the bracket. 7 plus 28y plus 10y equals 235. So we'll take this equation, write it down again so that we can see it clearly. Now, we can gather these two together. That gives us 38y. And we can take 7 away from each side, which will give us 228. Fairly big numbers coming in here. 228 divided by 38, because we're looking for the number which, when we multiply it by 38, will give us 228, and that's going to be 6. So we've established that y is equal to 6. Having done that, we can take it and we can substitute it back into the equation that we first had for x. So remember that for that we had x was equal to, and what we had for that was 1 plus 4y all over 5. And we substitute in the 6, so we have 1 plus 24 all over 5. And quickly we can see that's 25 divided by 5, so we have x equals 5. So again, we've got our pair of values, our answer to the pair of simultaneous equations. We haven't checked it though. Now remember that this came from the second equation. So really, to check it, we've got to go back to the very first equation that we had written down. And that one, if you remember, was 7x plus 2y is equal to 47. So let's just check. 7 times 5, that gives us 35, plus 2 times 6, that gives us 12. So 35 plus 12 equals 47. And yes, that is what we wanted. So we now know that this is correct. But let's just stop and think a minute. We've got all those fractions to work with. We've got this lump of algebra to carry around with us. Is there not an easier way of doing these? Yes, there is. It's useful to have seen the method that we have got, simply because we will need it again when we look at the second video of simultaneous equations. But there is a simpler way of handling these. So let's go on now and have a look at method 2. Now this method is sometimes called elimination, and we can see why it gets that name. And this is the method that you really do need to practice and become accustomed to. So let's start with the same equations that we had last time and see how it works and how much easier it actually is. Okay, method of elimination. What do? What we do is we seek to make the coefficients in front of the y's or in front of the x's the same. Once we've got them the same, then we can either add the two equations together or subtract them according to the signs that are there. By doing that, we will get rid of that particular unknown, the one that we chose to make the coefficients numerically the same. So, this one, what would we do? Well, if we look at this and this, here we have 2y and here we have minus 4y. So if I were to double that, I'd have 4y there and it's plus 4y, and I'd have minus 4y there. And that seems a pretty good thing to do, because then they're both 4y, one of them is plus and one of them is minus, and if I add them together, they'll disappear. So let me just number the equations, 1 and 2. And then I can keep a record of what I'm doing. So I'm going to multiply the first equation by 2, and that's going to lead me to a new equation, 3. So let's do that. 2 times 7x is 14x, plus 2 times that is 4y, equals 2 times that, and 2 times 47 is 94. Now equation 2, I'm leaving as it is, not going to touch it. Now, I've got two equations. This is plus 4y and this is minus 4y. So, if I add the two equations together, what happens? I get 14x plus 5x, that's 19x. No y's, because I've plus 4y, add it to minus 4y, no y's at all, equals 95. And so x is 95 over 19, which gives me 5. Which, if you remember, is the answer we had to the last question. Now we need to take this and substitute it back. Doesn't matter which equation we choose to substitute it back into. Let's take this one. X is 5, so 5 times by 5 minus 4y equals 1. And so we have 25 minus 4y equals 1. Take the 4y over to that side by adding 4y to each side. So that will give us 25 is equal to 4y plus 1. Take the 1 away from each side, 24 is 4y, and so y is equal to 6. And we've got exactly the same answer as we had before. And let's just look how much simpler that is, how much quicker that answer came out. One thing to notice, well, two things in actual fact. First of all, I try to keep the equal signs underneath each other. This not only makes it look neat, it enables you to see what it is you're doing. I keep the equations together. So the setting out of this work actually helps you to be able to check it. Second thing to notice is down this side, I've kept a record of exactly what I've done. Multiplying the equation by 2, adding the two equations together. And that's very helpful when you want to check your work. What did I do? How did I actually work this out? By having this record down the side, you don't have to work it out again. You can see exactly what it is that you did. Now let's take a third example. And again, we'll solve it by means of the method of elimination, just so we've got a second example of that method to look at. 3x plus 7y is 27, and 5x plus 2y is 16. OK, we've got a choice to make. We can make either the coefficients in front of the x numerically the same, or the coefficients in front of the y's. Well, in order to do that, I'd have to multiply, for the y's certainly, I'd have to multiply this equation by 2 to give me 14 there, and this one by 7 to give me 14 there. How do I make that choice? Well, fairly clearly, 2 times by 7 is 14, so 1 by 1, 1 by the other. But I don't really like multiplying by 7. Difficult number. I prefer to multiply by 3 and 5. So my choice is actually governed by how well I think I can handle the arithmetic. So let's multiply this one by 5 and this one by 3. Will give us 15x and 15x. So I'll number the equations 1 and 2. And I'll take equation 1 and I will multiply it by 5. And that will give me a new equation 3. So multiplying it by 5, 15x plus 35y is equal to 135. And then equation 2, I will multiply by 3, and that will give me a new equation 4. So here we go, multiplying this by 3, 15x plus 6y is equal to 48. These are now both 15x, and they're both plus 15x. So if I take this equation away from that equation, I'll have 15x minus 15x, no x's at all. I've eliminated the x, I'll just have the y's left. So let's do that. Equation 3 minus equation 4. 15x take away 15x, no x's. 35y take away 6y, that gives us 29y. And then 135 take away 48, and that's going to give us a 7 there, 87 altogether. And so y is 87 over 29, which gives us 3. Having got that, I need to know the value of x, so I can take y equals 3 and substitute it back, let's say, into equation 1. So I have 3x plus 7 times y, 7 3s are 21, is equal to 27. And so 3x is 6, taking 21 away from each side, and x is 2. Check this in here. 5 2s are 10, 2 3s are 6, 10 and 6 gives me 16, which is what I want. So I know that this is my answer, my solution to this pair of simultaneous equations. And again, look how straightforward that is. Much, much easier than the first method that we saw. Also, think about using letters as well. If we've got letters to use instead of coefficients that are numbers here, so we might have ax plus by, again, this is a much better method to use. Again, notice the setting down, keeping it compact, keeping the equal signs under each other, and keeping a record of what we've done, so that if something comes out wrong, we can check it, see what we are doing. Now, all the examples that we've looked at so far have all had whole number coefficients. They might have been plus, they might have been minus, but they've been whole number. And everything that we've looked at has been in this sort of form, x, y, number, x, y, number. Well, not all equations come like that. So let's just have a look at a couple of examples that don't look like the ones we've just done. First of all, let's have this one. X equals 3y, and x over 3 minus y equals 34. A pair of simultaneous equations, linear simultaneous equations again, because they've both got just x and y in, and numbers, nothing else. No x squareds, no xy's, etc. We need to get them into a form that we can use. And that would be nice to have it x, y, number. So let's do that with this one. X equals 3y. So we'll have x minus 3y equals 0. This one, got a fraction in it. Fractions we don't like, can't handle fractions. Let's get rid of the 3 by multiplying everything in this equation by 3. So we'll do that. 3 times x over 3 just leaves us with x. 3 times the y minus 3y equals 3 times this, going to be 102. Problem. These two bits here are exactly the same. But these two bits are different. What's going to happen? Well, clearly, if we subtract these two equations, one from the other, there won't be anything left at this side when we've done the subtraction. X from x, no x's. Minus 3y take away minus 3y, no y's left. And yet we're going to have 0 minus 102 equals minus 102 at this side. In other words, we're going to end up with that, which is a wee bit strange. What's the problem? What's the difficulty? Remember right back at the beginning when we drew a couple of graphs. In the first case, we had two lines that actually crossed. But in the second case, I drew two lines that were parallel. And that's exactly what we've got here. We have got two lines that are parallel. Because they've got this same form, they are parallel lines, so they don't meet. And what this is telling us is there in fact is no solution to this pair of equations, because they come from two parallel lines that do not meet. No solution. There isn't one fixed point. So we would write that down and simply say no solutions. And it's important to keep an eye out for that. Check back, make sure the arithmetic's correct, yes, but do remember that can happen. Let's take just one more final example. X over 5 minus y over 4 equals 0. 3x plus a half y equals 17. Now for this one, we've got fractions with denominators 5 and 4, and we need to get rid of those. So we need a common denominator with which we can multiply everything in the equation and thus get rid of the 5 and the 4. The obvious one to choose is 20, because 20 is 5 times by 4. Let us write that down in full. 20 times x over 5 minus 20 times y over 4 equals 0, because 20 times 0 is still 0. A little bit of cancelling. 5 into 20 goes 4, and 4 into 20 goes 5. And so with 4x minus 5y equals 0. So that was our first equation, that was our second equation, this one has now become our third equation. So equation 1 has gone to equation 3. Let's look at equation 2 now that we need to deal with. It's got a half y in it. So if I multiply everything by 2, this will become just y. So we have 6x plus y equals 34. And so equation 2 has become now equation 4. We want to eliminate one of the variables. Okay? Which one? Well, I'd have to do quite a bit of multiplication by 6 and by 4 if it was the x's that I wanted to get rid of. But look, there's a minus 5 here and a 1 there, so to speak. So if we multiply this one by 5, we'll get these two the same. So let's do that. 4x minus 5y equals 0. And then timesing this by 5, 30x plus 5y equals, and then we do this by 5, 5 4s are 20, 0 down and 2 to carry, 5 3s are 15, and the 2 is 17. So that gives us 170. And now we can just add these two together. So equation 3 stayed as it was. Equation 4 we multiplied by 5, so that's gone to equation 5. And now finally we're going to add together equations 3 and 5. And so we have 34x equals 170. And the y's have been eliminated. 34x is 170, and so x is 170 divided by 34, and that gives us 5. We need to go back and substitute into one of our two equations. Let's just have a look which one. Doesn't really matter. I think I'll actually choose to go for that one. Why? Because I can see that 5 over 5 gives me 1. And that's a very simple number and might make the arithmetic so much easier. So we'll have x over 5 minus y over 4 equals 0. And I'll take the 5 and substitute it in. 5 over 5, that's just 1. And so I have 1 take away y over 4 equals 0. So 1 must be equal to y over 4. If I multiply everything by 4, I end up with 4 equals y. So there's my pair of answers. X equals 5, y equals 4. And I really should just check by looking at the second equation. Now remember, our second equation was 3x plus a half y equals 17. 3x plus a half y equals 17. So let's substitute these in. X is 5. 3 x's, therefore, are 15, 3 5s, plus a half of y. But y is 4, so a half of it is 2. That gives me 17, which is what I want. Yes, this is correct. Let's just recap for a moment. A pair of simultaneous equations, they represent two straight lines. In effect, when we solve them together, we are looking for the point where the two straight lines intersect. The method of elimination is much, much better to use than the first method that we saw. Remember, also, in the way that we've set this one out, keep a record of what it is that you do, set your work out so that the equal signs come under each other, and so that at a glance you can look at what you've done, check your working. Finally, remember the answer that you get can always be checked by substituting the pair of values into the equations that you began with. And that means strictly you should never get one of these wrong. However, mistakes do happen.